start with. So let me introduce the speaker today. I'm really honored to introduce Illia Polosukhin. Is it right?
Yes.
Okay, he's a co-founder of a very well-known protocol. I heard once it was considered as a competing protocol to Ethereum, so it's really powerful technology. So his protocol was launched in 2020, and before Near, Illia worked in as announced in author AI research at Google, and he was one of the co-authors of the very famous paper, Attention is all you need, which actually revolutionized all the generative AI technologies these days. I recently checked the citation, it's like over
100,000.
100,000 citations, so quite impressive. So he was featured in Wall Street Journal, CNBC, Bloomberg, Time, Wired, New York Magazine, Vanity Fair, Financial Times, and TechCrunch. So without further ado, let me introduce Illia.
Thank you. Well, thank you very much for inviting me. It's a great honor to be here as well. Hopefully this will be interesting, inspirational. If you have questions, we'll have time to do Q&A at the end. But also if you have questions during, we can do that as well. So feel free to raise your hand. As was mentioned, my kind of origin story and background from Near as well has been in AI. And for me, kind of always natural language understanding, knowledge, reasoning being one of the core interests, because I do believe this is how we kind of make an advancement in AI. The way I say, there is thousands of species that can see, and there's only one that can actually talk and understand knowledge. And I'll talk through what led to the Attention is all you need paper and kind of what was the motivation. And then I left Google and we started Near AI, which was originally. Is this actually working? Yeah. Okay. And so when we started Near, it was actually an AI startup first. It was Near AI, and our kind of vision was to teach machines to code. And it's really kind of the motivation and is really behind that AI is transforming how we interact with computing. It's changing the way we're going to be, interacting with each other, with computing, with software. And so in 2017, this sounded like a science fiction. And now we know this is possible. And it leverages that to really kind of collect more training data for AI. Now, the broader vision, right, is we want everyone to control their own data, assets, and power of governance, power of choice, right? This is a vision that's beyond Web3, blockchain. It includes AI, it includes a lot of components. This is a vision about kind of self-sovereignty, empowering people to be in control and not have other parties, be that big companies or government, to kind of facilitate that. And one of the kind of on the Web3 side movements that we created around this is what we call chain abstraction movement. So for those who are familiar with blockchain, there's a lot of blockchains. There's layer 1s, there's layer 2s, now there's layer 3s. And it's very complicated. If you're not in Web3, like this all sounds ridiculous. And in general, if you come into a business or to, a new startup, for them, it's extremely complicated to figure out which technology to use, right? Is Near better? Is Ethereum better? Is Solana better? Should I be using this new hot mess that is giving me money? And so kind of our belief always from the beginning was that those are implementation details. We need to actually hide them from users and to some extent developers, and allow them to be able to leverage the benefits of blockchain Web3 to build their applications. And so that's what kind of behind this idea of chain abstraction. And so right now in Web3, we have this kind of highly fragmented situation, right? Again, for anyone who've been using blockchain, like each blockchain has its own set of apps. These apps, not actually usable by anyone else from who doesn't have an account on this chain. We have fragmented kind of experience, economy, liquidity, discovery of applications. This is as if you go to kind of internet and you're not able to actually visit some websites because they're serving from a different data center, right, or a different cloud. Like, oh, you can only use Amazon cloud services, not Google Cloud services. Like, that's kind of ridiculous level right now. And you also have like lots of accounts, lots of wallet providers, and it's kind of really complicated to manage all that. I have like 100 accounts across different chains. And so for us, this always been kind of the focus, like how do we abstract the blockchain? How do we make it really easy and connect all blockchains together? And we've been making a lot of progress on making it really easy for people to leverage blockchain across different spectrum, across different applications. So to achieve that, there's a lot of infrastructures that went into this. So one of the kind of first parts we started with is designing a new blockchain. Because blockchain is at the end what really facilitates the kind of ownership, security of the system, and it allows to kind of power everything else you build in Web3. And so the design decisions there were, how do we make it kind of invisible to the user, really easy to build for developer, and it's truly scalable that as we onboard mass market, as we bring billion user applications, they're actually not hit by limitations of the infrastructure and the needs. They don't end up paying more because somebody else is using this infrastructure as well. On top of this, we've been working across other blockchains now to provide some services that Near has. So we work with other layer 2s now, which are kind of separate chains that source security from Ethereum, but we provide them data availability services, which allows them to kind of reduce their cost for their users and developers. We have a fast finality layer, which allows to finalize and kind of provide faster proving for these layer 2s. And we're working on zero knowledge proving for WebAssembly, which is a generic, very kind of important component. But for us, it allows to also have kind of security proofs of the whole execution that are usable for many different use cases. So zooming into the layer 1, the blockchain itself. So kind of one of the core ideas is as we have more users currently in blockchain, the blockchain kind of has a limited capacity, which means that, if you add 10 times more users, what will happen is not that, you just have 10 times more users, it's actually the cost of operations goes higher. So Ethereum is a great example. As more users come in, actually cost for everyone becomes higher. And so some users getting priced out and they cannot use it because, like you will not pay transaction fees of $50 if you want to send somebody less than $50. And for us, it was a question, how do we design something that is able to scale as more demand come in? And so in traditional distributed systems, it's called sharding. We shard the database and we can continue growing number of machines that are storing data. Now, in a permissionless network, it's complicated because you can have malicious kind of actors who potentially not storing the data or trying to misrepresent it or affect it. And so we've designed a new kind of sharding paradigm for permissionless network. It's called Nightshade, and it's really trying to leverage a lot of the technology from erasure coding to kind of some of the blockchain specific things to provide a single blockchain from a user's and developer's perspective but that is actually sharded. So the block itself is sharded, and each part of the block is executed in parallel, has kind of different machines for ordering transactions. Then each part of this, each kind of shard gets erasure coded and sent to other validators to ensure that there's a way to recover data of this block, even if the validators in this shard are all malicious. And you have a lot of pieces kind of communication enrolled in this to make sure you have cross-shard communications happening as well. And so the cool thing is this is actually working, and we actually had a growth of usage on Near in March, and Near went from 4 shards, which we had for past year, to 6 shards, increasing capacity by 50%, pretty much showcasing how this works in production, that as you have more users, we can actually increase the capacity and continue having low fees for everyone. That's core idea. There's a paper about Nightshade if you're interested. We just published an updated version with actually what we call stateless validation. And this is the idea that to secure this, right, you don't want any validator in the network to be actually validating the whole blockchain, right? So even if the production is parallel, meaning you can execute things in parallel, you also don't want the validation, you want the validation to be parallel as well. And so we introduced the idea of stateless validation, where you can have nodes that don't even have any state or any kind of understanding of the current, of any shards, receiving block that contains all of the information required to validate it, right? So it's so-called state witness. It contains all the information about the state transitions that are recorded in the block, the transactions are recorded in the block. And that is enough to validate that this block is correctly applied and the new state is this. So example, you send somebody money and you include the balance, your balance and the receiver balance in the block information so that anybody can validate that indeed you had this much money before and the person had this much money before, and that after you send the money, the balances are updated correctly. So this does not require to have kind of the information now stored on the validators. What this means is you can have a lot more validators in the network, right? Because now they don't have any high requirements for their computing nodes. And at the same time, we can have kind of a lot more shards as well, because now if we increase the number of validators, we can kind of rotate them quickly every block. So this is actually coming in May, June this year. It's on testnet right now. And then beyond that, the kind of next phase is adding and changing number of shards dynamically based on the load. So kind of similar to auto scaling on AWS.
Those who are just beginners, could you explain what sharding means?
Yeah, so sharding is this idea that so right now, like for example, you're using Kakao, right? And let's imagine, there's one server, you send all the messages to this, and Kakao, send it to your friend who you're talking to. Now imagine there's 100 million users trying to use Kakao at the same time. Any single computer will get overwhelmed by amount of message received. And so what Kakao does is has multiple computers, right? So when you send your message, it goes to one of these computers, depending on who you are, and then computer handles it and sends it to the receiver. So that's the idea of sharding, is like you have more computers doing the same work in parallel, and then based on kind of where you are in the database, you kind of go to one of the computers that handles your specific account. And again, for blockchain, it's way more complicated because Kakao can just add more servers, right? They control them. They know this is their servers, so nobody can manipulate anything. In blockchain, because you're dealing with money, you're dealing with value, you're dealing with ownership, you need to handle also that any of the servers in the network can go rogue and try to steal everybody's money. And so you need to make sure that you have kind of a lot of additional verification, validation that's happening in the process. Yeah, so one of the interesting things is kind of as part of this process, there's a so-called data availability problem. So this is example of what you need to handle in the case of permissionless network is, let's imagine, one of those computers for kind of validating the shard is malicious, and they decide to, like the way to kind of steal money is actually not to directly steal money, is to not tell anyone what transactions are actually in the block, but then tell that the result is now I have a lot of money, right? And so that's a so-called data availability problem, right? The result, like they post the result, but they don't make the data available that created this result. And so if you don't have data available, right, you cannot validate that what they're saying is correct or incorrect. And so if you just kind of taking their word for it, right, they can go and steal, kind of create new money, double spend, or steal somebody else's money. And so the way this is addressed is you are actually requiring the data to be sent to other validators in the network. And unless validators receive the data, they don't progress, they don't build next blocks, or they skip kind of that validator completely. And so NEAR has that embedded in the protocol itself. But this problem is kind of a problem for a lot of other blockchains as well. So there's kind of a whole host of other chains, Ethereum O2, and so they have this problem as well. And so what we did, we actually offered what NEAR has as a service to them to actually use to reduce their costs, because NEAR has such a kind of cheap and very high throughput data availability for its own usage that it's actually can be sold, kind of offered to everybody else. Now, the other challenge is the experience, right? So I mentioned as a user, you right now, like I have, 10 different wallet providers and 100 different accounts, right? Because I'm transacting on Ethereum, I have NEAR, Cosmos, Bitcoin, and it's actually super complicated, right? Again, if you're not in blockchain space, this all sounds ridiculous because like why? Like it's like saying, oh, I need to have different credit cards because I'm paying on with different currencies, right? No, like one credit card should support all currencies. And so one of the technologies we also build is to offer that, is to have one account that is able to transact across all chains. And the way it works is it actually uses multi-party computation, which is another kind of cryptographic primitive, where every single kind of operator node does not have a private key, but when they come all together, they're able to sign messages but none of the individually are able to do that themselves, right? And so what this means is they together can, for example, sign a transaction, but not kind of neither of the nodes independently or a small group of them can collude to steal the money to sign these messages themselves. And so what we did as a product is we allow now kind of a single account to have addresses everywhere else and being able to transact everywhere else. Again, comparing this to your traditional banking systems, you now have one credit card which has balances in dollars, Korean won and euro, and you can kind of transact with all this, but you don't need to kind of think about individual chain and how that works. So that's the idea. Again, there's a lot more technology required because we don't trust any individual node, right? And you want to make sure that everything is secure as much as possible. And the other problem is every of this networks actually required to have fees paid as well. And so if you just have accounts, now you need to kind of deposit different currencies as well. Right now I need to figure out, oh, I need to put dollars here, Korean won there. And so we have also a so-called relayer network that when you request, for example, oh, I want to buy something with Ethereum or with Bitcoin, somebody else will kind of take that message, pop up your account with the right currency and pay it on that chain. And so again, with a credit card, I pay here with my American card in the store, right? Somebody else, does the exchange, right? I don't need to handle it directly manually. So that's kind of similarly to do that, but it requires to be in a trustless setup and in a way where no independent node can actually break the system. Finally, we've decentralized everything, right? We have kind of no trust across any of these layers. But if you've been using Web3, you still go to a single specific URL that's served from a server that actually is the front end for the application. And so what we also did is build decentralized front ends. This is where the application kind of front end, the UI that you're interacting with, the source code of it is stored on chain. And so when you go to any of the, we call them gateways that can kind of render this, they then go get the source code from the blockchain for whatever application you want to use and compose them for you on the front end, right? So there's no kind of now web server that is returning you the application. Now, all of this is done on your side, on the client side. And you have now cryptographic guarantees around which application you're using. This is important because there's continuous hacks that are happening around this level of interaction where users who are not familiar with what they're using are kind of signing transactions and stealing their money, right? And so this adds like additional guarantees around security, but it also serves as abstraction because now we can have an application that has different front ends for different smart contracts across different chains in one place. And so we have an application called TapTap that has over 150 different smart contracts in one place. So again, for those who are familiar with like WeChat, mini apps, like this is kind of the WeChat mini app, but decentralized, permissionless, and can use kind of across the whole world of applications. So with all this technology, right, the benefit is it's easy to onboard new users. And so Near has become over last year a top consumer application platform in Web3. So we have more users, kind of more active users than any other blockchain, with some applications having like 4 to 8 million monthly active users. Some of them having about 700 to 1 million daily active users like Kaiching and Hot. And so this is highly engaging applications that now have blockchain enabled with them and allow users to interact kind of across the spectrum of different things. Now, changing a little bit gears, right? So this is already kind of what we have, right? This is a basic platform. This is a permissionless infrastructure. If you look beyond this, right, what we see is kind of generative AI starting to change how things work, right? Because I would say that one of the biggest concerns with AI technology in itself is like highly centralizing power, right? And whoever has kind of control over it is able to create really kind of manipulative systems because you can kind of use it to directly interact with people, right? There's no more kind of additional layer of a human who is actually interpreting results of a computer. Now it can directly go and talk to everyone at the same time. And on the other side, we have kind of big tech firms and their incentives, right? If you're a big company like Google, you have already achieved your target market, right? You already have, 2 billion users. There's not that many more users in the world, that have computers and that have money to spend. And so what you need to do to continuously show growth, right? Because you go to, Wall Street and you need to show increase in revenue every year, is that you're trying to increase how much value you can extract from every individual user, so-called average revenue per user. And so to do that, you need to change their behavior, pretty much. And this is happening, it's not because like somebody at Google is evil, right? It's happening naturally because as teams decide which product to launch, as, should we have this model or this model, when you're evaluating, you're looking at what will affect revenue. And so you kind of continuously like making decisions, small decisions to big decisions that lead to increase in behavior change of the user to get them to spend more money. And so given these two things coming together, it's extremely dangerous situation that's going to be unrolling in next years, right? Because generative AI is extremely powerful technology to do that, and big tech incentives lead to kind of trying to extract more value from users. And so where I was talking about chain abstraction, right, this is kind of a core technology to allow everyone to be able to use this kind of Web3 technology, provide self-sovereignty. But as we look beyond, what we talk about is, we call it self-sovereign operating system. It's really kind of how do we transition from, okay, we have Web3, it's powerful, but it's still pretty limited, to how do we actually bring it across the board to every user. And so sovereign operating system, this is like a high-level stack of technologies that need to go into it. There's still Web2, standard operating system that we run on Android and iOS. There's a a lot about personal data management, right? Right now, our data lives in Facebook, our data lives in Kakao, our data lives in, your medical system. So it's all over the place. You don't actually own it. So we need to change that. We need to have a user-owned AI. I'll talk about what that means. We need this trustless interaction, kind of chain abstraction, blockchain level. And we need to have these experiences that are really generated and created for us, right? And what I showed with DevDApp, the really good kind of benefit there is it's actually training data for this level where the front ends themselves are generated for you, not just built by somebody. So maybe just to give you a quick background. So actually, who's here computer science students? No? All right.
Electrical, maybe.
Who's students? All right, great. So yeah, so for those who are not familiar, I mean, I'm assuming you all heard large language model as a concept. So language models are not a new thing. They've existed since 1950s. It's a kind of traditional statistical tool that's useful for various other applications, especially in natural language. But there's an interesting thing happened in 2013. And this is the idea that usually when we were doing natural language and kind of processing, we considered every word as a symbol, right? And it's really hard to deal with them because, if we write out like probabilities like this, you're starting to try to compute this, it's kind of super complicated, it's very sparse space. Now, what was introduced in 2015 is the idea of word embeddings, is that you can map every symbol, every word to a vector in a multidimensional space. And vectors are really easy to deal with because now you can calculate distances between them, you can rotate them, you can kind of do other math on them, which means you can then put them into deep learning networks and use stochastic gradient descent and actually learn your kind of objective function. And so kind of with the direction of word embeddings, language models became more powerful. We were using, so I joined Google actually right after this. Between word embeddings and cat neural, and I got really excited in deep learning. Now, we were doing recurrent neural networks. So this is the idea that you will read one word at a time as you are kind of processing, same as a human, right? We read one word at a time. And we kind of, build in our head what this document or article means, and then we can maybe go and answer a question. Now, the problem is this is very slow. And when you go to something like google.com, you don't want to wait for 20 seconds for it to read, Wikipedia article for you and answer a question. You want to answer right away, right? And Google specifically has requirements around latency on how fast you are able to respond. And so the idea of transformers, the model that's currently powering ChatGPT, Midjourney, and everything, it came from this kind of concept. It's like we wanted to really speed up the performance and use the fact that the kind of modern hardware, the hardware we have in laptops, but also even more with GPUs, is highly parallel. It doesn't need to read one word at a time. We actually can read all words at the same time. So if you watch the movie Arrival, science fiction movie from back in the day, the aliens there talk in the whole sentence at the same time. Like the whole sentence, they produce the whole sentence kind of as one symbol. And this is the idea. We actually use, we kind of see the whole article or even all articles in parallel, do self-attention, and then use that to answer questions. That was kind of the core concept. Like you take all the input and you transform it into output in parallel. And it's a very simple model, like at the end, because it removed a lot of the recurrence, it removed a lot of the kind of additional complexity, and because it's highly parallelizable, and importantly, can scale. And so as the number of parameters was increased, we saw a tremendous kind of increase in capacity and be able to reason. And so just to kind of show you to give you some intuition behind how it works. So you have this sentence, right? The cat drank the milk because it was hungry. And the important part, and actually it's been a pretty complicated like natural language processing problem, how to resolve it. Because like computers generally didn't have a common sense to understand that, given it's hungry, it only can be cat, right? It cannot be milk, right? That's a level of common sense understanding we need to have. It's called like vinaigrette problems. And so the idea here, you read every word in parallel. And so this is from a perspective of word it. You take this and you actually kind of look at every other word, right? And how likely, right, that it refers to every other word. And so you cannot do it actually in one step, right? In one step, you will look at everything and you will, it relates to hungry, it relates to milk, it relates to cat. But you can compress, you can bring all that information back into this vector and do it again. And so transformer model actually does it in multiple layers, and each layer kind of adds one level of indirect reasoning that you can have. And so this is kind of example, right? If you switch, it was sweet from it was hungry, right? It changes that this is now a milk. It refers to milk instead of referring to cat. And you can have multiple attention hats, for example, to think about different parts of the sentence. So this is kind of the model. Like what these models do is really they try to have semantic understanding about every word in the document. They look around the whole document to try to reason. They pretty much learn kind of mini programs, like mini common sense programs and mini reasoning programs by doing this. And they're doing it in multiple layers, right, of this reasoning. But usually it's like we use 6 layers of reasoning of this transformer model. So it's not as kind of recurrent as, for example, reading 2,000 or 5,000 word document kind of one word at a time. So extremely powerful model. We see a lot of interesting results now with ChatGPT being able to do a lot of things from coding to reasoning to writing essays, as well as people change the words to image kind of tokens, to DNA, to all kinds of other things. And now it's like this approach is highly useful across different modalities and domains as well. So what we see here is that AI innovation is accelerating, right? So kind of our expectation in 2017 was, we'll see kind of a hockey stick back then. It didn't happen, but it is happening right now. And a lot of it is coming from the fact that now you can talk with a computer, right? You can actually interact in natural language. And so a lot of the barriers that before, you needed to be a software engineer, for example, are starting to get removed, right? And, I have, for example, friends who are making AI game engine where you can talk to a computer to build a game. You don't need to write any lines of code, and you can build really interesting, engaging games by doing that, right? So we see those kind of examples, starting to really mature now. Now, behind the scenes, for those who have, played, for example, games in their gamer PC and maybe, know about GPUs, like those are not the GPUs that are used here, right? So nowadays, the way it works is there's a highly kind of specialized hardware that's used for training machine learning models. In a way, these are supercomputers. Each machine has usually 8 of this kind of processing units. Each one having like, I don't remember the numbers of teraflops. And importantly, all of these are, stacked into racks with number of machines, kind of connectivity, interlink, and you have lots of racks of this, right? And so the model, something like GPT-4, just to give you an idea, is 10,000 of this H100, right? So each one of this is one H100, was trained for 3 months and costed about $64 million to train. So a lot of it is now actually just very expensive, compute-heavy operations to train these models on large amounts of data, right? It was trained on 10 or 20 trillion tokens. So it read 10 trillion words, pretty much. You can imagine that, right? These models have 1 trillion parameters. So it's extremely kind of large and compute-intensive operations. And also important to note is, we usually think of like computers may be connected with Wi-Fi or internet, but the reality is these things are connected with a highly specialized connectivity, they call it NVLink interconnect. And the current kind of what people use is somewhere between 600 to 900 gigabyte per second. So if you compare this, your CPU to RAM in your laptops can send information only at about 200 gigabyte per second, right? This is faster to send data from one GPU to another GPU in another rack than it is from inside your computer, from your CPU to RAM, which is like usually considered, like you don't even consider that speed, I think. Now, NVIDIA just announced actually a new chip, Blackwell, which is 1800 or 1.8 terabytes per second of connectivity. So it's extremely high speeds. That's what I'm saying. These things are not your gamer, GPU. It's really specialized supercomputer hardware that costs, hundreds of millions of dollars to deploy and to build and, training these models. Now, the flip side of this is we have kind of this big companies who can afford doing this, which are kind of building AI models, and they're offering a way to access it, right? You can use Gemini, you can use ChatGPT, but we don't know what goes inside them, right? There's a lot of kind of decisions that happen before you actually use, the model that affect how it works, right? And there's a lot of teams, not computer science teams, not engineering, but ethics, legal, curation, etc., which end up affecting how you see things. And again, to give you an example, it's not, for example, because somebody's evil in any way, but if you just scrape internet, on internet, Barack Obama, who was two presidents before in US, there was a conspiracy that he was born in Kenya. And so people love talking about conspiracies. So on internet, if you just look at documents, you'll see as likely people say Barack Obama is born in Kenya as if he's born in Hawaii. And somewhere somebody, right, needs to decide if you want to remove these documents, right? If you want to remove this conspiracy theory or not. And it's a very subjective decision, right? And so that decision goes into the data set. And again, these models at the end, they're just learning whatever's in the data, right? And their common sense, their understanding, their reasoning is based on this data. You have also, legal team that says, okay, we cannot use these documents, like we cannot do Wall Street or New York Times because, they have copyright requirements. And there's ethics team which says, hey, this is not ethical, and so all these decisions are made, right, that affect what you see in result. You also, we don't have this yet, but we will have advertisement teams, monetization teams who are changing results to actually generate more revenue. And this is where I think the most danger comes in, because these companies have such a pervasive incentive to change results to generate more revenue from the user. And so this is kind of really dangerous, as well as, we see already a ton of kind of challenges happening, right? The companies, we have regulators who are trying to figure out if OpenAI investors are misled. We have Google pretty much being, having massive backlash on kind of the images they generate because they're trying to fix, the bias in the data and models. And so reality is we kind of in a weird state where, because it's so expensive, open source and academia doesn't have resources to build these models, right? Maybe you can fine tune it a little bit, but you don't have kind of resources to do it from scratch. And at the same time, these models, we don't even have the source, right? Like even if the weights are open source, right? Llama 2, for example, has open source weights, but we don't know what data went into it. And so you actually cannot even do proper analysis on why decisions are made like this, because we don't know what went into it. We have kind of currently no way to protect ourselves from this manipulation and misleading that's happening. And it's going to happen even more, right? And there's already a lot of cases where people use this AI tools for nefarious reasons, for malicious reasons, for crime. The economics of these big tech companies, right, is that they will continue pretty much trying to extract more revenue and then invest more into building better models to extract more revenue, right? This is just kind of a whole loop of incentives. The regulators I don't really understand how to regulate this, right? This is not like expertise of people, like, you know, very low level technology that is extremely quickly updating as well. And the way they planning to do it is actually going to threaten even more open source, you know, academia and kind of decentralized approaches, because they'll try to put more restrictions, and restrictions always lead to pretty much that bigger companies can, you know, pay like their way through this, and smaller companies don't have resources to do this. And so there's a kind of a case for open source AI, right? For really creating a set of incentives and the environment in which we can have kind of open source user-owned AI that is on the user side, right? Again, the models right now, if you're inside Google, you're going to be optimizing that model to be trying to generate more revenue for Google, versus what, you know, we should expect is models that are actually on our side and trying to benefit us and maximize our value. So there's a lot of pieces that needs to come together. I'll not go through everything, but, you know, this is like high level kind of stack that combines Web3 and AI and brings these pieces together. So one of the pieces actually is the content. So right now, because this language models are so easy to kind of affect the internet, they, you know, it's really easy for them to pretty much become a bot that joins every chat and starts to convincing you that you should vote for whatever candidate, right? And this is not science fiction. Somebody's building these startups right now, which are like trying to affect the overall population opinion. And the thing is, like, those problems are not really language model problems. Like, this problems have existed before, they exist now. You know, Photoshop existed for a while. You know, false information. I really like this example. A journalist wrote a piece, and then somebody just edited a title, took a screenshot, and published on Twitter. And then this journalist got a lot of shit for that, because they thought that this is the real article, right? And so, like, this is not, you know, high-tech, sophisticated attack, right? This was just people modify the title inside the browser. So the reality is we need a new way of how we handling content. And so somewhere 15 years ago, 20 years ago, we had this state where everything on the internet was not encrypted. Literally, if you were sitting in a coffee shop, you could actually see what everyone else is doing on the internet, including what passwords they were entering and credit cards they were entering. And we had a transition that happened, which was to have encrypted communication with servers, so-called HTTPS. And so we need similar thing to happen now on the content level, on individual image, video, and piece of text. So you actually know who published it, where it's coming from, kind of the history of it, as well as you can have additional information about community talking about this. And for that, we need cryptography, we need kind of on-chain reputation, we need different pieces of Web3 stack to power that, and we need integrations into browsers and kind of websites. There's a flip side of this, which is because the machine learning models now will be the interface with which you're going to be reading news and consuming content. You know, the future TikTok is not going to be you watching a bunch of people. It's going to be generated for you feed based on what people are doing, right? You'll not actually see potentially even direct content that people are putting together. We need a new way of pretty much people contributing data that they get rewarded for, that then gets used for training models and for inference. And so the idea here is we can have a data network where the content can be contributed to, and people, authors, content creators, are getting payouts based on how novel it is. And then whoever builds models and builds a new TikTok, like AI TikTok, etc., are paying royalties for using this data. So again, this is like leveraging Web3, leveraging incentives to actually create a bigger data set than some of the centralized platforms like Facebook have, to really enable a more powerful kind of network and make it in the open and reward creators more fairly. The other piece is the current state of AI is there's, I don't know, 700 different evaluation data sets that people are evaluating on, and then they say like, oh, I'm on average better than, you know, this model, or on average worse than this model. And so this is kind of lack of standardization, but also lack of kind of a effective way to manage input from people, what's important for them from these models. And so one of the things we actually are working on is streamlining this evaluation to really have people provide what's important for them, what are the inputs, and then we can actually validate all models and provide a clear indication which models are better based on what the real people actually asking. And so for that, you do need to coordinate a lot of people. And this is, again, this is something that we started with in Near AI back in the day. So the other piece is infra. I'll just mention kind of one of the challenges right now when you call into OpenAI, right? They can run a model and give you an answer. They can not run a model and give you an answer from like some cache. They can also run a different model. They can modify this model. Like you have no idea what actual results you're getting. And so if you imagine, especially in a more decentralized place, or if you have a very important decision to be making, right? Like what to invest, or, you know, if this person has, for example, disease or not, you want a way to have a probability that it came indeed from a model, and the model, like from a specific model, a specific correlation. And so there's a few different ways to do this. There's a zero knowledge way, there's an optimistic kind of, and there's a cryptoeconomic way. I'm not going to go super deep into this. There's a good post by Hasib, but I would say like the big important part right now is none of them are particularly working yet for the scale of models we are trying to do, because it's actually very expensive to do zero knowledge proofs. They don't scale yet. Optimistic requires like a lag, and it's not private, and cryptoeconomics requires a lot of nodes to actually kind of reproduce the work. And kind of one of the big challenges is all these models operate on floating points, right? So it's not the integers, but like 0.1, 0.33, etc. And the thing is, different computers, different CPUs, different GPUs represent the same number in a different way, kind of. And because the algorithms, like even if you pretty much multiply two of the same numbers on different computers, you actually receive different results. I mean, it will be a little bit different. And it's especially true about different GPU architectures. So like as they actually change the algorithm. And this leads to like, if you are actually doing it in a decentralized way and you have lots of nodes kind of replicating your work, you will get different results just by nature, even if you're doing exactly the same inputs and do the same mathematical operations, you'll get different results. And so that is extremely kind of hard to fix in this environment, because like to actually get you cryptoeconomic and kind of incentives similar how we use it in blockchain, where we have deterministic computation across the board. So this is just like something that like is currently in research on how to do this effectively and be able to provide these proofs. I'll just mention another part, which is I'm actually exploring, is how do we get maybe instead of one big model, right? So like, again, GPT-5 is going to be like even bigger than GPT-4. GPT-4 is already a huge model, requires, you know, a ton of H100s, which are very limited. Can we have lots of smaller models that are have maybe different specialization? They're better, different models are better at different things. And then you are coordinating this set of kind of experts to answer your specific question, right? So you don't ask all of them all the time, but if you're, you know, have a financial question, you go to the models that are more specialized in financial decisions. If you have a medical question, you go to the medical ones. And the cool thing is we can actually use the financial incentives to have these models to be improving, right? We can actually pay them better, more, right? If they're getting better over time. And if you have this kind of more diverse specialization happening. And this is where evaluation, you know, some of the probability, and this all tying together into one network. Finally, there's a lot of different applications. And one kind of thing right now, everybody's using the word agent for everything. And it's a little bit confusing. And so I'm kind of adding a little bit of way to think about it, right? Because there is kind of discrepancy between if this is a tool or if this is an autonomous agent, right? So ChatGPT, for example, is a tool. You give it a request, it gives you a response, maybe it goes and does a little bit of work for you. Versus there's something like Agent GPT where you give it a task, like a mission, and it goes and figures out how to do it for you. You have things like Llama, which is just open source AI framework. You can use it in centralized way, you can use it in decentralized way. You can have a model that runs on your device, right, that you tell what to do. And so it is in a way very decentralized, right? There's no central server that runs it. But a decentralized kind of autonomous is something like AI governance, where it makes decisions on itself, right? It's only given the high level goal and it's able to go and make this decision itself. And so there's different types of agents by how you specialize it, how its output looking like, and its level of autonomy, as well as is the kind of different infrastructure used as well. And so there's like a lot of different kind of options here you can imagine. And so we actually build an AI registry for kind of these agents with different types, which you can build and kind of customize with decentralized front ends. So they actually are kind of autonomous and can use either your local LLM, OpenAI LLM, or decentralized LLM as well. So have all of those options kind of there. The other really interesting is, we have this kind of assets on chain, and they usually are programmed with, Rust or Solidity or something. And so you can imagine having assets that are programmed with natural language, right? You describe pretty much a contract in English that includes, how to interact with the real world. For example, it can include, read the news if, this candidate wins president election, do this, right? Now, this kind of opens up a huge space for possibilities what to do. The only challenge is current language models are not robust, right? It's really easy to convince them of something that's not true. And there's actually a specific ways to do this. So this is called jailbreaking, where you can tell the model, you can pretty much use, if you have an open source model, you can figure out what you want the model to output, and you do backpropagation. So you kind of use what you do usually for training these models to see what inputs would lead to this output. And so by doing that, you can actually find exact instruction you need to give to the model to convince it in something that it's not. There's also another method, which is you use the model itself and you tell it that it's trying to break itself as like for testing. And then after a few iterations, it actually figures out how to break itself. It's actually a pretty cool method to do that. So there's a lot of ways for this. And in our ecosystem, somebody launched a project which is leveraging this concept to actually trade different assets against each other, where people can go and convince that it should sell one asset for another, and you need to convince the AI pretty much to do that, right? So AI is making decisions what to buy to sell, but it's designed to be like kind of you want to convince it to do that. The cool thing about this is that it actually collects training data to know how these models are convincible, right? It's creating a data set now then to train the model to not be affected by this inputs. So it's kind of an interesting, like a multiplayer PvP game, but that produces a very valuable data set on the other side. The other thing I mentioned is experiences. And so we have a project that is what you want as an application, and it generates you a fully working front-end application that then can go and connect to the smart contracts or your backend. And so the idea here is that the development will go from writing a bunch of JavaScript to just describing the interface and maybe modifying it with a little bit more prompting and natural language. And so we'll see a lot more of this starting to happen, where instead of using existing software as a service or an application, you'll build applications for yourself, because it's going to become easier and you can get exactly what you want, the minimum experience, kind of minimum UI you need, and not overwhelmed by all the features everybody else asks. So the kind of beyond that, there's this idea that you can imagine the future work will actually start to change as well, right? We already saw kind of gigs, like, everything like Uber, starting to transition from, a full-time employment to smaller jobs, kind of individual jobs. And so you can imagine as the AI agents get better at some jobs than others, if you have a gig marketplace where you say like, hey, implement this feature or translate this text, some of those jobs still getting picked up by people and some by AI agents. The cool thing is on blockchain, there's no difference between if you're a person, if you're an agent, or if you're a cat, right? Like you're an address on chain that can transact. And so you can imagine a gig marketplace that includes AI, like a verification loop as well, where anybody can come in and request some work to be done. And you have kind of a pool of workforce, both human and AI, that actually doing this work in combination. And as it's happening, you can now have businesses that are fully run by AI because you can actually just, ask AI to split work into smaller tasks, put it in this marketplace, some of it gets done by humans, some of it by AI, you pay for it, and then you generate value on the other side. So we'll see transition happening where kind of the new types of businesses, which are more kind of AI driven than people driven, that's going to emerge. Now, if you kind of take one step further, you can imagine this happening for governance as well, right? So, and it's going to happen in Web3 first because Web3 has a lot more kind of smaller units of governance, right, with some money to make decisions. But we can imagine this also transitioning for other use cases. But the way to do it is to have a reinforcement learning agent now, where you give it, for example, a utility function. So you say you wanted to maximize, happiness of people, you wanted to grow its treasury, and it's actually going to be trying to make actions that lead to improve this utility function while trying to predict and model the world around it. And so I'm expecting to see a lot of this kind of use case happening and testing this out. So just to kind of finish, I mentioned like we have a lot of the tools already, right? AI has matured as well, but we have this kind of fork in the road where we're going to have kind of centralized companies by the fact of disincentives and resources, which, will continue kind of trying to extract more money, change the way people behave. Or we figure out how to create a more open, self-sovereign, user-owned path and leverage these tools we built to really enable that. So yeah, I mean, this is pretty much all for talk, but yeah, we'd love to answer questions.
So we have like some time for questions. Any questions? Don't be shy. Yeah, go ahead.
When you use error correction code, or is the error eraser code, right? What is the code rate that you guys typically using, and how is it code rate related to validators? What type of protocol validators?
Yeah, good question. So we use the I'm going to space out an exact name of the encoding, the Shamir encoding. But the way it works is pretty much, so every validator pretty much encodes their part of the block into pretty much 3x parts. So it's enough to have kind of 1/3 of the parts to pretty much decode it back. And then it sends it to other validators in the group. And so then, even if pretty much all validators in that shard, right, go offline or malicious, etc., 1/3 of the rest of the validators is enough to recover this block.
So like a jumping fault tolerance type of algorithm.
Yeah, well, I mean, this is like around that we have a consensus with BFT tests.
Mixture of expertise adopted in the transformer model. If there are a lot of experts, then not all the experts can be loaded on the GPU memory, so I think their model itself can be memory bottleneck. There are general solution to tackle this memory bottleneck.
Yeah, so for mixture of experts, I mean, right now, all of the top models are mixture of experts. So like GPT-4 and Grok is open source, right? They're all mixture of experts. There is actually enough RAM right now. So like the A100s have like the higher tier A100 and H100 have 80 gigs. So if you have like 8 of them on one machine, you can actually load all the mixture of experts. And right now the bottleneck is in compute. The approach I'm suggesting is actually where they don't sit in one machine. They don't live in one, and so you actually distributing pretty much the kind of experts on different machines, and then you routing requests across them. So this is kind of a way to solve as well compute and memory and this. But again, right now the way mixture of experts are done is like 2 out of 16. And so like 16 experts are fitting on kind of 8 A100s, for example. And yeah, so like people just find the configuration that fits and doesn't have the kind of memory bottleneck.
Any other questions?
I'm not really about I have the first one of talking about ethics in AI. So I do have recently we can train AI in ethics like 2 months. So and then we have an idea of the freedom of jailbreaking. Yeah, I'm curious about that.
Yeah, the question is kind of ethics in AI and jailbreaking. So this is, I mean, my personal opinion, I think twofold. One is ethics is very different across different countries and different communities. And from my kind of the point of some of the talk is that we should have open source models that then you can take and you can adjust with the ethics that you have or your community or a group of people have. Because right now relying that people sitting in San Francisco, for example, sharing exactly the same ethics as people, for example, here in Korea is not very realistic. And then on jailbreaking, I think we do need to get these models to become robust, right? Right now, the way they trained, right? They trained on 10 trillion words pretty much of predict the next word. And then we fine-tuned them on 100,000 records of like, do what I'm asking you to do, right? And so mostly they know how to like predict the next word, and a little bit they know how to actually like, execute exact commands. And so we need to address that problem that like just practically speaking, they mostly just very good at jumping with no context into a document and trying to predict the next word, right? So like think of it as, they're really good at like trying to figure out a model of the new environment and do this. And so all the jailbreaking is based on that. It's like trying to change the environment of the model to make it pretend to do something, right? And that's why all the jailbreaking kind of works that way. Is because it leverages kind of its original training. So we need to either adjust how we train originally or adjust how we fine tuning them for instructions to kind of fix this problem.
Seems that you guys are trying to combine AI and blockchain together. But clearly, blockchain are researched and invested for a long time, but it still does not generate any reserve in the industry. So, in your thinking, what is the main core problem of the technical or political issues of the blockchain?
Yeah, so I mean, as I showed the example, right? We have about 10 million monthly active users across a few applications. And so I would say that like there are results, right? So for example, for Kaichain, they switched from using Stripe, right, which is a traditional kind of payment system, to use Near, and their transaction fee went down 100x. Because microtransactions in traditional financial system is extremely expensive. There's a base fee of like 25 cents for any transaction, like credit card transaction. And so similarly, you know, Play-Amber, like Sweat issued a new type of asset, like asset that values your movement, right? This is not something you can do in kind of traditional world. So we do see kind of results now and real users and real applications kind of happening. Now it's not obviously like, you know, everybody's now using it yet. And this is not any more technical problem. It was a technical problem a few years ago, right? We've been kind of this whole space been fixing technical problems, launching a lot of the kind of, you know, scalable networks and providing improving experience. Now a lot of it is creating interesting use cases and then solving some of the kind of like regulatory / like final onboarding problems, right? Because at the end, this is a financial system, a new economic system. And if you cannot connect, right, I cannot pay with crypto directly for the stuff in the store, right? It limits how much usage can it have. But again, this is something that's being fixed right now. There's a lot of, for example, applications launching support for cards. So for example, Sweatcoin is planning to have Apple Pay and Google Pay integrated, so you'll be able to pay directly with your assets from there. And so we'll see a lot more use cases like that, where it's actually connected with the traditional system as well.
For you, my question is, the first question is, when do you think the people will use Web3 as they use the traditional web now? Like, I want to know about your anticipation about Web3 is used universally. And the second question is a little bit silly, but if everything becomes decentralized and there are no centralized big tech companies, then where does all the money goes to?
Yeah, so pretty much my expectation. So far for Near at least, we've been growing 10x every year, right? So we had 1 million users, you know, beginning of 23. We have 10 million users beginning of 24. I don't know if we're going to continue on the same trajectory, but you know, if we do 10x twice more, we have 1 billion users, which is kind of our goal. But I mean, practically speaking, what we need, as I said, is like some more integrations with more of the real economy as well. So we like, for example, we see people starting to switch. So Hot is integrated in Telegram. It went from 0 users to 4 million users in about 2.5 months. So this is like one of the fastest growing applications, like not just in Web3, Web2. And this is, you know, the users there are starting to use it for payments because there's actually 0 transaction fees on stablecoin payments. There's like a bunch of games are launching, etc. It's like a whole platform. And so generally speaking, I think as we see more of these use cases being truly launched, now leveraging scalable infrastructure, we'll see the actual growth coming in, and then more integrations are going to follow as well. But I think what will happen is you will not even know for the most part that you're using this. Because like, so Kaiching actually, it's pre-installed on Oppo and Xiaomi phones. So if you have Xiaomi phone, I mean, it's not enabled in Korea, but if you're in Southeast Asia, you're probably using Near already. You don't know about that. You just have payments and loyalty points, and you know, you're just using it. You can pay for coffee in Singapore, for example, with Kaiching, which transacts on Near. So the idea of kind of chain abstraction is that you will not know about that, like unless you really want to, but you can leverage this new financial system.
Is it like separate application, or is it running on your main?
It's a separate application, but it uses Near. So Near is infrastructure, right?
Okay.
So
Okay.
it's like internet, you know, everybody's using internet.
There was another third question.
Oh, okay,
Yeah.
similar to Web3.
Okay. Okay, you have a question?
I saw on-chain finance and use AI governance, something like a DAO. With a problem, of course, because LLM produces the correct output, is there a solution? Or there any preventive measure, or there is a system for claiming compensation for damages?
Yeah, so I mean, I would say like I would not recommend right now LLM to be the final decision maker. So we definitely need to get them a lot more robust. That's why this example is literally like it's a toy, right? But it's a toy that's very useful because it has a little bit of money to play with and it collects very valuable data, right? So this is again an example where you're convincing it to buy another asset, right? And so people come in and convince it, and like people convince it back, and so like it's constantly changing like what it swaps back and forth. But the idea is that this collects this training data where we see how easy this model is to convince, what are the examples, like how people doing it. So you can train the model now to not be affected by that. And so what we need to do, we need to get this models to a level where it's not easy to jailbreak them. And especially like it requires some set of, figuring out methods as well as training data to do that. But yeah, I mean, over time, the kind of the examples I showed were more over time as we get more robust with this.
Maybe a few more questions?
Can I ask
Yeah,
one?
yes.
So, let's suppose there are two companies. A is a very good company. He wants to give power to the people, sovereignty, right? Yeah. There is another company, C, is a centralized AI company that has a lot of money, a lot of GPUs, right? How do company A compete with the B?
Yeah, that's a very good question. It's also related. I didn't answer to the question of where if there's no centralized companies, where does all the money go? So there's few things that happen, right? Kind of broadly speaking, there's indeed like a flywheel that a centralized company has, which is, makes more money, it's able to invest more to make better tech, and then this better tech is able to make more money, right, by kind of enabling people. The benefit of kind of Web3 is that your quote unquote shareholders are the users, right? And so you're able to kind of turn this around and make it that the value and kind of the way you generate value is now not from manipulating people, but from actually organizing people to work together, right? So you're able to have a very different structure of organization. So Near, for example, is not one company, right? We have a lot of different companies working together, kind of facilitating around the platform. And so the idea here is like, we can kind of coordinate more diverse talent, people, organizations, institutions, academia to work together to achieve results. And indeed, it's not going to be like as even potentially effective because you have so much, application, but it's going to be more robust. And then at the same time, it has its own flywheel. As more products are launched, more value is created, the economy is becoming bigger. The more money is coming in, the more money is coming in because invested more now into creating, into getting more access to compute, into creating more new products. And so kind of we see this with crypto. Now, crypto is sadly also very cyclical in the sense that it like moves too fast up and then the result moves too fast down, but the kind of overall trajectory is growing. So it's like high volatility, system, but it allows also to accumulate resources and create and invest them into creating better infrastructure and more value. So it's all flywheel in the more coordinate people and kind of attract more value through that.
Is there any special tokenomics or tokenomics good fit for this strategy?
Yes. Coming soon.
Okay, I maybe have one question, kind of technical, but on your protocol is a well-known trilemma, security, scalability, and decentralization. What kind of improvement do you think you have made in your protocol?
Yeah, I mean, the idea is we kind of, I think this trilemma is a little bit
Overrated?
well, not overrated. It's a little bit limiting because it's missing the time concept.
Oh, okay.
Because, like, for example, I can create a 1 terabyte big block, right, with everybody's transactions, and then I'll ship everyone a hard drive, right, with this, and it'll take like a day or a week to arrive. And then now we have all received the, this big block of transactions, and we can confirm that it's true, right? And so, so the idea here is like the latency of how long it takes for you to actually receive and confirm something is an important concept. And so we trying to actually find a balance between all these things where we want to have ability to scale so we can add more capacity to the network. And we are kind of willing to balance the kind of latency of one block kind of coordination with like that not everyone will validate everything in the network, right, because of sharding. But at the same time, still have decentralization because we can have as many validators now with status validation as possible who are randomly will validate the block. Now, at some latency, at some time, everybody will revalidate everything, but the idea is like there's a trade-off between kind of latency, decentralization, and throughput that we're taking this like balanced approach. But yeah, the big kind of offering is really we want to have capacity growing. Like again, I really like the Netflix example. Imagine you go to Netflix and it tells you, sorry, this movie is busy right now. You need to come later, or like you need to pay more, or you need to switch to a different data center because like it's busy right now. So like this should not happen, right? We should have capacity in the network.
So what is your current latency per block?
So we have a 1 second block time right now. Yeah.
Okay, maybe one last question or before the, okay, yeah, the last question.
I'm actually curious about what would be the driving force of the movement from Web2 to Web3? Because I think most of the usable data are, I think they are already in Google or Meta or in big tech. So yes, I want to know about how you think about what would be the driving force of the movement.
Yeah, so I think the biggest force will be this kind of user ownership, right? Right now, for example, in Korea, Korean companies cannot use any of these models because they're all outside of Korea, and there's a law around data locality, right? So Korean companies need to have actually their own local models that they can run. They need an open source model they can run that they can run inside their data center, right? Now, it needs to support Korean language, right? Which, OpenAI, for example, probably doesn't care much, right, about Korean language. So you need to fine tune it. Ideally, you need to know what went into training data, right? So there's a lot of kind of just like requirements that actually coming in from the real businesses that as you digging in and you kind of step outside of like OpenAI and Google, like that are there, that are needed and people are working on. And the more we have in open source, the more we have kind of tooling available, the more people will want to use it as well, because it will start becoming better results, right? So for example, this project, Sakana, which is also another author on attention that you need, they just introduced the models for Japanese language because the company is based in Japan, and they did state of the art, right, by like combining a bunch of open source models. And so like this is kind of examples where open source can now do things at least on the maybe not at the like base kind of where the most training data exists, but on the other levels. And then as that becomes more mature and stronger, I'm sure we'll see also starting to be results of the centralized companies as well.
Okay, let's thank the speaker. One quick announcement, there's like a seminar, there's a meetup. So if you want to talk to the speaker in person, it's a really good chance. And also there are some refreshments, and we heard there are some beers. So if you want to beer, please join them and just enjoy. Okay, thanks a lot.
Thank you.